Okay, so this is chapter 10. We're going to start counting methods. And problem 1 says that Alan, Bill, Kathy, David, and Evelyn are students that are on a debate club. Each member can be represented by the first letter of their name, that is A, B, C, D, E. Okay. Assume that no one can hold more than one office. Also, Kathy and Evelyn are the only women in the group. Okay. Part A lists the number of different ways for choosing a president and a treasurer if the president must be a female. President and treasurer must be a female. Okay. Write your answers as a set. Okay. So if the president and treasurer must be females, the president could be Kathy. C A. Kathy and Alan, Kathy and Bill, Kathy and David, Kathy and Evelyn, or Evelyn could be the president, and so it could be Evelyn and Alan, Evelyn and Bill, Evelyn and Kathy, Evelyn and David. Okay, so that'd be that'd be it for choosing a president and a treasurer if the president must be a female. Okay, part B lists the number of different ways for choosing a president, a secretary, and a treasurer if the president and treasurer must be women. Okay, so the secretary, I guess, has to be a man since there's only 2 women in the group. If I start with Kathy, Alan, and Evelyn could be 1. Kathy, Bill, and Evelyn. Kathy, David, and Evelyn. Okay, and that's all the options there with Kathy, president, and Evelyn, treasurer. What if Evelyn is the president and Kathy is the treasurer? Okay, then Alan could be the secretary, or Bill could be the secretary, or David could be the secretary. Okay, so we're going to have 6 ordered pairs. By the way, they want us to write our answer as a set, which is important. That's how the book is going to want it. Okay. Problem 2: roll a pair of ordinary dice and assume that the dice are easily distinguishable. Perhaps one is red, the other one's green. In the order pair little r, little g. Little r will represent the number showing on the red die, and little g will represent the number showing on the green die. Okay, so any number that I roll on the red die, I'd have to list that first. Anyone on the green die, I'd have to list that second. Okay, so list the outcomes and write your answer as a set. Okay, well, if I have a pair of 1s, or if I roll a 1 on the red die and a 2 on the green die, a 1 on the red die and a 3 on the green die, a 1 on the red die and a 4 on the green die, a 1 on the red die and a 5 on the green die, a 1 on the red die or a 6 on the green die. That'd be all the options if there was a 1 showing on the red die. Okay, and then move on to if there's a 2 showing on the red die. So you could have a 1 showing on the green die, a 2 showing on the green die, a 3 showing on the green die, etc. All the way up to a 6 showing on the green die. Okay, and then what if we have a 3 on the red die, okay, or a 4 on the red die, and then a 5 on the red die, and then a 6 on the red die. You have a 6 on the red die and a 1 on the green die, a 6 on the red die and a 2 on the green die, 6 on the red die and a 3 on the green die, etc. All the way up to if both the dice show a 6. Okay, so there's going to be 36 ordered pairs that are listed there. Part B lists the number of ways for which the sum of the 2 numbers of the dice is 9. Write your answer as a set of ordered pairs. Okay, so let's see. I need to think of all the ways that I can get a 9. Now, I can only roll up to a 6. Okay, so I'm not going to have like 2, 7 or 1, 8 or anything like that. Okay, but 3 and a 6. Is one option, a 4 and a 5, and then what if I flip the pairs? So I get a 5 on the red die and a 4 on the green die, or a 6 on the red die and a 3 on the green die. That'd be all the ways for rolling a 9, okay, which would be 4 ways. Part C, list the number of ways for which the sum of the numbers of the dice is less than 5. Okay, so well, if I have a 1 and a 1, that gives me a 2, that's less than 5. A 1 and a 2, that gives me 3. A 1 and a 3, that gives me 4. Okay, 1 and a 4 I'm not going to want because that's I need the two numbers to be strictly less than 5, not equal to 5. Okay, so that's all with a 1 showing on the red die. What if I have a 2 showing on the red die? Well, I can have a 1 on the green die, so a 2 and a 1 would be 3. A 2 and a 2 would be 4. 2 and a 3 would be 5, so, and I don't want 5. I want any all the outcomes that are strictly less than 5. Okay, so move on to a 3 on the red die. Okay, if you have a 3 on the red die, you could have a 1 on the green die, or a 2 on the green die. Well, if I have a 3 on the red die and a 2 on the green die, then that gives me a sum of 5, right? And I don't want that. So again, make sure that your answer is written as a set of ordered pairs, okay? Which is how the book is going to want it. Problem 3, a coin is tossed 3 times. Let H denote heads and T denote tails. List the outcomes and write your answers as a set. Okay, so I could have all 3 flips being heads, or I could have only 2 of them being heads and 1 of them being a tails. Okay, the one tails can come either first, second, or third, so you can go tails, heads, 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 tails, heads, or heads, heads, tails. Or you could have only one of the flips being heads, the other 2 would be tails. The one heads come either first, second, or third. Okay, so there's going to be 3 more elements that I'll need to list here. Could go heads, tails, 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 heads, tails, or tails, tails, heads. Or, of course, all the flips could be tails. Okay, and so I close up the set. List the number of ways for getting at least 2 heads. Okay, so while I can see my answer is going to be part of this set. So anything that's at least 2 heads means 2 heads or more. So if we got 2 heads, then there's 1 tails, right? The 1 tails can be the first, second, or third. Or all 3 flips could be heads, okay, if you'd have at least 2 heads. And it looks like there's 4 ways to get at least 2 heads. Part C, list the number of ways of getting fewer than 2 heads. Okay, so if I got fewer than 2 heads, then that could mean that 1 of the flips could be heads. The heads can come either first, second, or third, or none of the flips could be heads. Okay, in which case they're all tails. So it looks like there's 4 different ways of getting fewer than 2 heads. Problem 4, list the number of 3-digit numbers that can be written using only the digits 1, 2, and 3, assuming that repeated digits are not allowed. Okay, so if I start with a 1 first and then 2 second, 1, 2, 3, maybe a 3 second, so 1, 3, 2. Okay, and then move on to if you have a 2 first, so 2, 1, 3, 2, 3, 1. And then if you have a 3 first, you can go 3, 1, 2, or 3, 2, 1. Okay, and that'd be all the values then for if I'm only using the digits 1, 2, or 3. Okay. Problem 5 says, how many triangles of any size are in the figure below? Okay, so I went ahead and I've marked, let's see here, it looks like 6 vertices, and I groups of 3, and then I'm going to go through the list and then cross off any group that would not form a triangle is the plan. Okay, so We start with all the groups of three where A is leading off. Okay, so I got A, B, C, and of course I don't want to repeat a letter. Okay, so I don't need A, B, or something like that. Okay, A, B, C, A, B, D, A, B, E, A, B, F. Okay, what if I have C second? Well, I don't want A, C, B because I've already got A, B, C. Okay, and so I really wouldn't have said anything different there. But A, C, D, A, C, E, and A, C, F. Okay, what if I have D in the second spot? Okay, A, D, B, I don't want that because I've already got that group of three. I don't want A, C, D because I've already got that group of three. A, D, E, okay, and A, D, F. What if I have an E at the second spot there? A, E, F, okay, would be the only group of three there. And by the way, that's going to be all the groups of three where A is one of the three letters. Okay, so now move on to if B is one of the three letters. And I've already got some listed here where B is one of the three letters there. Of course, I got to pay attention to that because any one of those groups of three involve A. Okay, so I'm not going to do anything more with A. But if I have B, C, D, and if I list all the ones where C is the second spot, B, C, E, or B, C, F. What if I have D at the second spot there? Okay, so B, D, E, B, D, F. Okay, and what if I have E as the second spot? So B, E, F. Okay, and that'd be all the groups of three where B is one of the three letters. Okay, now move on to if C is one of the three letters. Okay, and if C is leading off, and again, I've already got some groups of three listed where C is one of the three letters, so I've got to pay attention to that. Anything listed there with A or B is not going to be an element because I've already got that. So let's see here. C, D, E, C, D, F, and C, E, F are going to be groups of three. Okay, and then move on to if D is one of the three letters. Okay, and again, I've already got a couple of groups listed there with D is one. So the only one that I haven't listed would be D, E, F. Okay, now that I've got all the groups of three listed, I would go through and cross off any groups of three that don't form triangles. Okay, so A, B, C forms a triangle. A, B, D forms the biggest triangle. A, B, E forms a triangle. A, B, F forms a triangle. A, C, D forms a triangle. Okay, A, C, E forms a triangle. A, C, F forms a line. I'm not counting lines, I'm counting triangles. So get rid of that one. A, D, E forms a line. I don't want that one. A, D, F. D and F don't join together, so I'd eliminate that one. Okay, A, E, F forms a triangle. B, C, D forms a line. I don't want that. B, C, E forms a triangle. B, C, F forms a triangle. B, D, E forms a triangle. Okay. B, D, F. Well, D and F don't join, so I get rid of that one. B, E, F forms a line. Again, I'm not counting lines, I'm counting triangles. C, D, E. Yeah, that forms a triangle, so I count that. C, D, F. D and F don't join, so I'm not going to count that. C, E, F forms a triangle. and then D, E, F, but E and F don't join. D and F. D, E, F, D and F don't join. So all in all, let's see if I were to count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there should be 12 triangles in this picture of any size. And by the way, this is one method that you can consider. Of course, I won't always use this method because there could be many things to list. Okay, and so it's kind of specific to the problem. But anyway, this is one option that you can consider to use there. Okay, let's see here. I'm going to stop the video right there, and we'll pick up with number 6 there in the next video.